Okay, new material for today. We're looking at something called the inverse function. And I want to describe the inverse function by talking about a little example. So we've got a backyard paving company. That's what they're lovingly called, the backyard paving company. And they charge $10 a square foot for installing paving stones, plus a $50 delivery fee for showing up and bringing all their stuff. So this is kind of similar to something you probably did in grade 9. This is a linear equation. So you probably would have seen things in grade 9 where it's like, can you write this as an equation? So the company calculates the cost to a customer as a function of the area to be paved. And Tom wants to express the area in terms of cost to see how much of his yard he can pave for different budget amounts. So in this case, we've got a little table of values here. And of course, usually we call the one on the left, we're going to call that X, and the one on the right, we're going to call that Y. And we know what they actually represent, the area paved in square feet and the cost in dollars. And we can make ourselves a nice little table of values from this, right? So just as a little bit of practice right now, I'd like you to fill in the rest of this table of values. Just a quick reminder of how we got here. We said, okay, we're going to do 40 square feet times $10 for each, plus the $50 delivery fee. Okay, so just as a little bit of practice right now, I'd like you to take 60 seconds, and I'd like you to calculate what's going to go in those other 4 boxes. So we've got 450, we've got 850, we've got 1250, 1650, and 2050. So I'm sure this takes you back to grade 9 math, filling in our table of values, right? But that's an important skill that we need to have. And if we want to write this as an equation, here's how we would write that as an equation. We'd say, okay, we'd normally write it as y equals, but let's go back to grade 9 and use our y equals notation instead of our f of x. So we'd say y equals 10 times x, because it's $10 for every square foot, plus the $50 delivery fee. So that's our linear equation, right? It describes this. And we could graph that if we wanted to use Desmos. So let me get a Desmos up here. All right, so if we're going to graph that in Desmos, we'd say 10x plus 50. And there's our function. All right. Now let's think about this in a slightly different way. What if we wanted to describe this the opposite way? What if instead we wanted to see, well, how many square feet can I do depending on my budget? So if I have a budget of 850, how many square feet can I get done? What if I have a budget of 1250? How many square feet can I get done? What if I have a budget of 1650? How many square feet can I get done, etc.? So this is essentially the same problem, but it's a different way of looking at it. What we've actually done is we've actually swapped our x and y coordinates. So what used to be in x is now in y, and what used to be in y is now in x. Okay, so let's fill those in. We know 850 is 80. We know 1250 is 120. We know 1650 is 160. And we know 2050 is 200 square feet. So essentially it's the same problem, but we've swapped the x's and the y's in our table of values. And so this is going to look a little different when we graph it, because now our area would be on the x-axis and our cost would be, or sorry, our cost would be on the x-axis and our area would be on the y-axis. Now it's a little less obvious what this function would be. So what would be the equation of this? The other one was easy. It was you take the square foot and you based on the problem here, you multiply it by 10 and then you add 50 to it. That was a nice easy equation to write. What would we write for this equation? Well, I actually know, but I'm not going to show you how just yet. The equation for this is going to be y equals x minus 50 over 10. That's going to be the equation for this line. So I actually want to put that on my Desmos graph. Y equals x minus 50 divided by 10. So let's add a new expression. I'm going to call this one g at x so they don't get confused about which is which. So I'm going to go x minus 50 divided by 10. Okay. Now these two lines have a relationship with one another. And it might not be obvious what that relationship is based on just looking at it. But what I'm going to do is I'm going to put a little mirror in here. And this will allow you to see it. And the mirror I'm going to put in is just a straight line going at a 45-degree angle. So what that is, I'm going to say q at x for my new function, equals x. That's just my line that goes through the origin, and this has got a slope of 1. Through the origin, and it's got a slope of 1. Y equals x. That's what that line is. And this line is essentially a mirror for the two different functions. So they look like they're mirrored on either side. Okay, so when we rewrote the function by flipping the x and y values, what we ended up with was a new function that was a mirror image of the other one if our mirror is at that y equals x line, that 45-degree angle line. And if I were to, this is one that I did in Desmos earlier, so same thing you just saw, but I've got my points on here. And what we'll notice about those points is that this one over here got mirrored by this one over here. Essentially, it's just like a reflection in the mirror. Same here, we have a reflection in the mirror between those 2 points. Same here, we have a reflection in the mirror of those 2 points. Same here, we have a reflection in the mirror, and here we have a reflection in the mirror. In fact, any point on those lines is just reflected in that y equals x line. Okay, so we started with an example of a paving company to make it something that's a little bit accessible. But what we're doing here, this is called our inverse of a function. Our inverse of a function, where we're flipping our x and y values and we're getting this thing that we can see in a mirror image. So I'm going to throw a little screen on here, and I'm going to give you some notation for how we're going to write this. Okay, so here's our notation for our inverse function. When we're writing our inverse function, we compare them like this. Our first one we call f at x, because that's our function notation. That's how we write functions. Our inverse we're calling f at -1x. So it's just like in trigonometry when we were talking about doing the inverse of sine, cosine, and tangent in trigonometry. It's the same sort of way. This doesn't mean that this thing has an exponent of -1. It does not mean that. It does not mean that it has an exponent of -1. That is just to indicate that we're talking about the inverse. So if you see that, that means it's an inverse of the original function. So how do we figure out what an inverse of a function is, where the x and y values are flipped? Well, there's three ways to do it. So I'm going to take you through our three key ways, and then we're going to try some examples of these three key ways, okay? And you're going to need to be able to do each of these three. So here's our three ways. The three ways to determine the inverse of a function. Here's our first one. We're going to use a table of values. We actually already did this one. We're going to take our table of values and we're going to switch the columns in the table of values. We'll flip our x's and our y's. So here's a table of values. And my first one, I'm going to call f of x. That's my name for this function. And this next one I'm going to call f inverse. So I've labeled them so I know which is which. Let's use the coordinates of our normal quadratic, our y equals x squared. So our normal quadratic would have coordinates of negative 2 is what I want to start with. Negative 2, negative 1, 0, 1, and 2. That's how we usually will do our table of values for that function. And that means our y values, 2 squared would be 4, 1 squared would be 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So that's our normal quadratic, our parent function. That's our quadratic. Now if we're going to flip these, here's our new coordinates of our inverse. These are coordinates of our inverse. I got a 4, a 1, a 0, a 1, and a 4. Those are my x values now. My y values are negative 2, negative 1, 0, 1, and 2. So if I have a table of values, I flip the x and y values, that allows me to graph my new function. That'll give me the inverse function. So that's way number one. With a table of values, you switch the columns in the table of values. Method number one. Here's method number two. We're going to do it graphically. So we're going to do it graphically. So we know that when we do it graphically, we're going to have to make a reflection in that line f of x equals x. That's our straight line with a slope of 1. Y equals x. So I'm actually going to take this and I'm going to put it on the grid. And I know it should go through point 1, 1, and 2, 2, and 3, 3, and 4, 4, and 5, 5, and negative 1, negative 1, negative 2, negative 2. It should go right through all of those points. So it should go through the origin, and it should go through all of those points. So there, I've drawn my line. This is going to be my mirror, and it's going to reflect everything. So this first function, y equals f of x, is the blue dots. I'm going to do a red one now, and my red one is going to be y equals f prime, and we say f prime for this of x. That's our reciprocal function, anything you see in red. So what I need to do is do some reflections. So I'm going to start with the point right here. I'm going to start with that point right here. The reflection for that is on the other side of the mirror. It's over here. Now let's reflect this one right here. The reflection for that one is on the other side of the mirror, right over here. Now let's do this one right here. Reflection for that, it looks like it's 1.5 squares over. So there's a half and there's 1. It's going to be right here. How about this one right here? Okay, I see to get to that one, I'm going to go through one box, through 2, so through 1, through 2, so it's going to be right here. So far so good. I've just got a couple left. I've got to reflect this one up here. its reflection on the other side of the mirror is going to be right over here. And finally, this one down here. It's going to be reflected up here. And you can start catching on to these by just, you can count like 1, 2, 3 squares, 1, 2, 3 squares. Or I could notice that this point, the one I'm going to circle right here, has an x coordinate of 4 and a y coordinate of -2. So that means the reciprocal, which is up over here, should have a x coordinate of -2 and a y coordinate of 4. So I could just look at it and draw them in, or if you find it easier, you can actually write in the coordinates and then flip the x and y values and then put in the new coordinates. Now if you're drawing a straight line, like a linear function, this is actually really easy. You can just pick 2 points on your function, because we know if we draw a line through those 2 points, that's going to be our straight line for our function. You can pick 2 points, and then for each of those points, you just flip your x and y values and plot your new point, and then draw your new straight line, and that's going to be your reciprocal function. So you can just take the x and y coordinates of the points and flip them, or you can just do it by looking at it and saying, where would that reflection end up on the other side? Okay, so that's our graphical one. Let's try another version of the graphical one. Let's try this one down here. We've got a straight line, and we want to reflect this in the other side. So let's just do a couple of points. I'll do this one in blue. In red first, let's name it. This is going to be f at x, and blue is going to be our reciprocal function. So let's pick a couple of points on here. I don't know, let's pick this one right here because it goes right through the grid lines. And that is at 1, 2, 3, 4, 5, 6 x value and 2 y value. Let's pick another one right here. That is at 2x value, -2 y value. Okay, so let's reflect those points. 6 and 2, if I want to do the inverse, I'm going to make it at x value of 2, 1, 2, y value of 6. 1, 2, 3, 4, 5, 6. That's right here. So that's at 2, 6. Now I bet you could have just looked at the line and drawn it and reflected it on the other side. That's good. If you can do that, that's great. But I want to show you this method with the points because I think it can be an easy way to do it. And -2 and 2, so we got to reflect it on the other side. That means we're going to have an x value of -2, 1, 2, a y value of 2, 1, 2. That's going to put it right here. You probably could have just looked at it and known where it would be on the other side. But this is maybe a more careful way to do it. And now we got to draw a straight line through there. So I'm going to grab a line. I'm going to make it blue. And I need to have my line go right through those 2 points. There we go. Okay, so that's my graph of my inverse function. Now you can do the same thing that I just did with a quadratic. A quadratic, it's hard to draw if you only have 2 points. Usually you want your 5, you want your vertex, and then you want 2 points on one side and 2 points on the other side. And so the vertex would be, or a quadratic would be a little easier to draw if you did more points. And I'll show you how to do that in one of our examples. Okay, so that's our second way of doing it. Way number 1, table of values, switch x's and y's. Way number 2, graphically, make a reflection in the y equals x mirror. Here's number 3. Some students like this one the best, and some students like this one the least. I actually used this method right at the beginning, if I skip back there for a minute, when I got the equation y equals x minus 50 over 10. Where did I get that equation from? Well, I'm going to show you how I got that equation right now. So here we are, we've got a function f of x equals 5 minus 2x. I'm going to do this algebraically. I'm going to get the equation for the inverse. I'm going to switch my x and y values, and then I'm going to solve for y. And that's going to make my inverse. Okay, so I'm going to switch my x and y values, and then I'm going to solve for y. So here we go. First thing I'm going to do is I'm just going to rename this y equals 5 minus 2x, right? So I'm replacing my f of x with a y. And then I'm going to do like a big line here that says I'm not continuing on with the same thing. I'm going to shift gears here. And now I'm going to switch my x and my y. I'm also going to change colors just to make it obvious that I'm doing something different. So I'm going to put my x where my y was. And I'm going to put my y where my x was. And now I need to solve for y. I need to get y by itself. So first, if we're going to get y by itself, let's subtract 5 from both sides. That's going to leave us with negative 2y on this side and x minus 5 on this side. And now I'm going to divide both sides by negative 2. To get y by itself. So I end up with y equals x minus 5 over negative 2. Okay, so that's my reciprocal function, and now I'm going to write it like that. I'm going to say f at x with a negative 1 equals x minus 5 over negative 2. So this is my inverse function. I flipped my x's and my y's and I solved for y. This is my inverse of that function I gave you originally. Let's actually try graphing these on Desmos and see what they look like. So 5 minus 2x is our first one. That's what our first one looks like. Our next one, I'm going to call it g at x, just because you can't use function or inverse notation on here. You won't know what we're doing. What did I have? X minus 5 over negative 2. Here we go. So I'm going to put some brackets in here. X minus 5 divided by negative 2. Okay, and now finally let's put on that mirror line. Let's go, oopsie. There we go. That's my mirror line, and I can see it makes a nice mirror where these things are mirror images of one another through that line. So it worked. Okay, so those are my 3 ways. Those are my 3 ways. Those are the 3 ways you need to be able to do this inverse stuff. Is you need to be able to switch the values in your table of values. You need to be able to, on a graph, draw the mirror image using points or just by figuring out how far it would be on the other side of the line. And third one is algebraically. Switch your x and y values and then solve for y. Okay, I want to try a couple examples and then we're going to do some practice on this. So here's my first one. For this function, y equals 1/2 x minus 4, that's a linear function, it's a straight line. Figure out the inverse function and sketch them both. Okay, Well, for sketching this one, I can probably sketch the first one without too much trouble. Because I remember what I got here. This value is my y-intercept. Right? So that's 1, 2, 3, 4. That's going to be right here. And this value is my slope. So my slope is rise 1, run 2. So rise 1, run 2, right there. Rise 1, run 2, right there. Rise 1, run 2, right there. So that's my line. It's going to go through those points. So let's put a blue line through there. Oh, it's the wrong color. I'll have to fix that. Let's make it a lovely shade of blue. There we are. Okay, so that's my original one. My other one should be, my inverse should be mirrored in there. Okay, so let's do the inverse. Let's do it algebraically. Let's do it algebraically. So first thing I'm going to do is I'm going to switch my x and my y. So I'm going to say I'm going to put an x here. I'm going to put a y here. And now I'm going to solve for y. Let's add 4 to both sides. Now let's multiply both sides by 2 to get rid of that half. Now I could multiply that through the brackets, right? I could end up with 2x plus 4. So that's going to be my inverse function. So I'll say the inverse is 2x plus 4. And what do I know about that? I know a couple of things. I know that that is my y-intercept, and that is my slope. And I know that from our grade 9 math. So my y-intercept is at 4. Oh, I did this one wrong. I hope someone was telling me that. My first one, my y-intercept was -4. So that should have been way down here. So I made a mistake. I need to move my other one here. The nice thing is, I can just grab what's here. There we go. I can just grab all this and move it down. I hope some of you caught that. And we're just being polite and not telling me. Okay, here we go. -1, -2, -3, -4. There we go. That's better. So I have my slope of 1/2, up 1 over 2, up 1 over 2, but my y-intercept is -4. 1, 2, 3, 4. That's better. Okay, good. Now let's do my inverse. Let's graph that. Got a y-intercept of 4, 1, 2, 3, 4 right here, and a slope of 2. That's the same as saying 2 over 1. So rise 2, run 1. Rise 2, 1, 2, run 1 right here. Rise 2, run 1 right here. Rise 2, run 1 right here. So let's do a green line that's going to go through all these points. Like that. And there we have it. So I've graphed my regular function and my inverse. Let's take a quick look at a kind of like a pre-prepared graph. So this is one I did in a program like Desmos. And that shows the exact same thing with that mirror line. All right. And hey, you out there, I'm pointing at you. If you were one of those students that said, hey, Mr. Roy, I think Mr. Roy made a mistake. Isn't that y-intercept at -4? Isn't that supposed to be down here at -4, not up there at +4? Good on you. Awesome. But next time, let me know if you think I've made a mistake. I do occasionally make mistakes, more often than I care to admit. Okay, that's our first example. Let's do another one. Let's do one. Oh, that's a quadratic. Ah, this is going to be harder. Determine the inverse of the following and sketch both. Ugh, okay, well, this is going to be tough. I bet I can just sketch the first one though. I bet I can start there, and that'll be not too bad for me. Let's start by doing that one in blue. Is that what I did last time? I did my basic function in blue. Yeah, let's do that. Starting function in blue. So here's what I know about a basic quadratic, right? It starts at the origin right here, and then it goes up 1 and over 1, like that. And then it goes over 2 and up 1, 2, 3, 4 right here. So that's my basic quadratic, right? That's just my y equals x squared. I'm going to actually draw that in like that. And like that. Close enough. But I notice I've got some changes here. So what have I got going on? I'm shifting 3 up. And I'm shifting 1 to the right. Because it's a negative, which means it's going to actually send me in the positive direction. So 1 to the right and 3 up. So let's actually grab my, ooh, not the graph. Let's grab my function here. I think I got all my pieces there. And we're going to go, come on. Be nice. This one here. Oh, yeah, you're right. I see what you said. Wouldn't that be 8? Yes, good call. And on here, you're right. That is 8 on my actual one. Thanks for catching that. Okay, let's fix that up before we go any further. Boy, I'm having one of those days. Yeah, 2x plus 8. Good, that's better. Okay, so our slope is fine, so we don't need to change that. All we need to do is change our, shift it up a little bit. So let's grab my line, and I'll shift this up to 4, 5, 6, 7, 8, right there. Awesome. Thanks for catching that, Emma. There, that looks better, doesn't it? Okay. Let's get our eraser and change this as well. And that's going to be an 8. Okay. Beauty. We're rolling again. Okay, let's get back to our quadratic. Ugh. So what I'm going to do is I'm going to take this quadratic, and I'm just going to move it up 3 and over 1. Okay, so I'll grab the whole thing. I'll go up. I wonder if this is going to let me do it. If not, I'll just have to move the whole graph. Which will be a funny way to do it. There we go. Up 1, 2, 3, and over 1. There. So I've done my transformations and shifted my quadratic. I think somebody might be unmuted. So I'm hearing a lot of noise. Maybe not. Maybe I'm just getting some background noise. Okay, so let's move on. So I've drawn my function, and I've just drawn my basic quadratic, and I've transformed this one and moved it over. That's the easiest way to do it. I could have done a whole table of values, plugged in values of x, all that kind of stuff, but that's a nice, easy way to do it, right? Okay, let's do my inverse function. Here we go. Let's do my inverse function with green. I'm going to draw a line here showing I'm not continuing the same thing. I'm starting something new. I'm going to put my x where my y was, and I'm going to put my y where my x was. So I'm going to switch it around so it looks like this. Now I need to solve for y. I need to get y by itself. So here's what we're going to do to get y by itself. First thing we'll do is subtract 3 from both sides to get rid of that 3. So I'm going to go x minus 3 equals y minus 1 squared. Now I'm in a bit of a pickle. How do I undo something being squared? Ooh, I know. I got to take the square root. If I take the square root, that's going to undo it being squared. So I'm going to say, okay, let's take the square root of both sides. And it gets rid of that squared. But there's a catch. And here's the catch. The square root of something could be positive or it could be negative. And if you're not sure what I mean by that, I'm going to say, what if I had something where I said, let's go with x squared equals 4. You'd say, oh, I know what that is. Take the square root of 4. X has got to be 2. And you're half right. X could be 2 or it could be negative 2. Right? Because negative 2 squared is 4. And 2 squared is also 4. There's two answers, two possible answers. So I have to do the positive one and the negative one. So I have to put a plus or minus in there because it could be either of them when I take the square root. I don't know which it's going to be. It could be either. There's two possible situations there. Finally, let's add 1 to both sides. So we're going to end up with plus or minus root of x minus 3 plus 1. And that's going to be my inverse function. Let's write it as such. I'm going to go f to negative 1 to the x is plus or minus x minus 3 plus 1. Now what does that actually look like? Well, we've graphed a thing like this before. This is just our square root function. So we can actually do that on Desmos, right? X minus 3 plus 1. Square root of x minus 3 plus 1. Let's go to Desmos and do that. So first I'm going to put on my other one. I'm just going to call it f at x. And I'm going to say, okay, that one was my basic quadratic, but it was shifted up 3 and to the right 1. So I'm going to go x minus 1. Oops, what happened? There we are. X minus 1 squared plus 3. That's my quadratic. That's my first one. Now I want to do my inverse. I'm going to call this g at x, I suppose. And I'll get my keyboard here and I'll put my little square root function in there. And I'm going to say it's going to be x, what was it? Let me make sure I'm getting it right here. X minus 3 plus 1. X minus 3. Oh, let's put some brackets in there so it's all under there. X minus 3. And then I'll move out from under there and put a plus 1. So there we go. But that's only half of it. I need to do that's the plus version. I need to do the minus version as well. So I got to put a new expression in, and I'm going to have to do this in 2 halves. Because Desmos can only graph functions. And what I'm about to do isn't a function. It's not going to pass the vertical line test. So let's do the same thing. Let's go negative, though, this time. Square root of x minus 3 plus 1. So that is I'm going to have to draw my quadratic in 2 halves. This one I just did is not a function. It doesn't pass the vertical line test. But it is the inverse of our original quadratic. Let's put our mirror line in there. And you'll see that it's a mirror between the two. Creates a mirror image of the two. I'm going to show you this on my graph using some points though. So let's get our little mirror image line. Let's put that on there. Okay, there's my line. That's going to be my mirror. And now I'm going to draw my reciprocal function. So I can say, oh, okay, it's just going to be reflected. The vertex is going to be reflected over here. This point is going to be reflected right here. And this point is going to be reflected, 1, 2, right here. So that's my first half, like that. And my other half I know is just going to be an exact copy. So I can just draw that in like this, because it's symmetric. So there it is. There's my inverse. Okay, so that's a little trickier with a quadratic. Using Desmos can be helpful, but this one actually is pretty easy to graph. If you graph the first one, we know what it looks like. We know it's a basic quadratic that's just been shifted up and over. And then we can just use that mirror line to draw in our new one. So it's actually pretty easy to sketch quickly and easily by hand. But using Desmos is always an option you have available to you. Personally, I think that part took longer for us. Okay, so I want to stop there. For the 11M class, you're actually going to be using the 11U textbook for this, because I think the stuff is better. So I think everyone will just use the better one. And so I want to take some time to practice right now, but first I think we should take a break. We've been going for a really long time. It's almost 11 right now. So let's resume at 10 minutes after 11. Make sure in your break you're getting up, you're moving around, you're getting out of that chair. Grab a snack or something like that, and we're going to be diving in on some practice work at 10 minutes after 11. Okay, so let's take a break now. I'll see you at 10 minutes after 11.